Alright, hi everyone. I thought I'd give an update on how my language compiler or my programming language was going. I'm taking a break now, but I'll just show you how far I got. So originally I didn't use ASTs at all. I kind of used a lazy way of doing it because, I mean, my language is very similar to C++, so you can kind of just convert them easily. But the problem with doing that is you don't have much control, and you don't have any way of checking, and it's just kind of hard, especially when you have like complicated expressions. It's very hard to separate them if you do it that way. Eventually I did it another way, and now I've switched over completely to ASTs, but the ASTs I use are kind of a bit different to the traditional way. But anyway, I'll show you how this works. So the last thing I was doing, I think, was just making a parseInt function, just because it's kind of useful, and also just shows you what your program doesn't have. It's just an easy way to test stuff. It just make stuff that you want to use and see if it works. But I'll show you the process. So it's just literally it just calls convert code, which has 4 processes. So it's first pass the tokens, build ASTs, check it if it's correct, and then convert to C++ or LLVM or whatever you want to convert it to. I'm using C++ here for now, but I'll show you what this does. For now, I think I'm just converting. Yeah, I'm converting this code. So this is the parseInt. All right. First, I'll go to the top. What this does. So here's my code in my language. And then here it is in C++. The formatting is terrible, so I'll just copy it and show you how this looks. Alright, so first of all I create a slice, which is just a struct with a pointer and a length, because it's just safer to have a length. So if you have a string, or you have, I don't know, an array, I want to have the length as well, so I use slices for everything. So the original code was what? It was yeah, string. So a string basically converts over to a slice of const char. So that has to convert over, and then I have what, a pointer to an i32, which converts to a pointer to an int32t. So basically, I mean, we've got a lot of if you want to check stuff. Say for example, you want to have index checking with an array, or you want to have something like array access, yeah, index checking here, for example. So here we have an array access. If you want to check it, you can't have it in a massive expression. How do you check it? So basically you separate it into separate variables. You have const char equals this, and then you could have something like, you could have a function like something like this. You can have char, or whatever it is, whatever. You can make it generic if you want, using using templates. So you'd have like a check. So like if index is, you know, higher or than the length, then you'd return something. But it's basically, if you want to do this, then you could just put here safe array access, and then yeah. Anyway, I haven't done that yet. It doesn't matter. It's just for if I do that in the future. That's basically why you separate it. It's because you want to check stuff. But also the problem is when you separate it is you have to know what the type is. So here it's a const char. Here it's a bool. You can't just presume what the type is. So if there's an equals equals, you got to set this to bool. Stuff like this. And then yeah, basically it's exactly the same code as before, because we're literally just passing an int. So the original code was if input higher than 0 and input, basically if there's a minus at the start, we're checking for that. Then we go through and basically, yeah, just multiply the value. And we have this weird C minus, which is kind of weird, C minus 48, which you kind of separate this to check for overflows, because again, you'd basically have something like safe minus, or so a C here is a const char. That's a bit kind of weird, because you'd have like a const char minus 48. It's kind of weird. Anyway, this is a weird way of doing it. But anyway, this does work, so I can show you this. If I just say I put in 1 2 3 4, it's expected to be 1 2 3 4, and we create the slice, and then we pass it in, and then get the result, and then it does work. Yeah, pass number 1 2 3 4, so it does work. But I'll show you how this actually works. So we have parsing, formatting, analyzing, convert. I'm done. It will say an error. I'll show you an error later, how that works. So we have the C++ code, and we have some debugging stuff. So first we have the list of tokens, which is basically what you need to convert into. And then we have the ASTs. So ASTs are basically, they're almost like a linked list, basically. So they're like classes with data inside classes of data inside classes of data, and they can basically go really, really deep. Like these are quite far. So we start with the function declaration of parseInt, and inside that we have all this, and everything's nested. Then we have return type parameter with all the parameters. Then we have the function body. And inside the function body we have the if statement. It's like basically you have like the function, inside the function you have a body, inside that you have an if statement, inside the if statement you have a body, inside it's like that kind of thing. Cool. So you have this AST node. So first we have an AST node type. So basically what is it? What's the type? Is it invalid? Is it comment? Invalid is just default basically. If it's not set to anything, it's invalid. It should be set to something. So it's return, continue, print line, integer literal, loads of this stuff basically. Anything, well, what's the category? What is it? Then we have a token. So basically it's kind of like it could be anything. So it could be a return. If it's a return, you need some kind of, you need either a value or nothing. If it's say, I don't know, a function, you'd need middle would be parameters, left would be the return type, right would be something, the body, I guess, in this situation. That's kind of how it works. The one problem you do have with doing it this way is having just generic left, middle, right, is you kind of forget what they're for. I think I made a map somewhere. It's very hard to actually remember what all these things are. So if it's int, then you get, again, it's a child, and the number would be the name of it. That's the name. And then the value. Also, these can nest a lot. So you can have, like, for example, if you have this, like, a variable that's this value, you can have a function declaration, a function call inside it. You know, you could nest all the way down. If it's an array, then it's like, this is the name, so it's the token and the child. Left is the, it's just array, it doesn't really do anything. And then the var type is left. So left. You've got to kind of recursively call these as well. But yeah, it's hard. I basically had to make this so I could remember what the hell anything is. Because generally what people use is they would use kind of polymorphism, and they'd use different kind of, they'd use like about 20 different classes or something like that. I couldn't be bothered to do that, so I basically just did this. But it does mean you kind of forget what everything's for, but you can help it. You can make it easier if you simply, if I go to convert CVP, I can show you some examples. I think here's a good example. So I've tried to give these good names and separate them into sections. I'm using assert just to see if it's null or not. With the problem with assert, it crashes the program. Generally, I don't like using exceptions. I just avoid them entirely. I just think they're clunky. I just don't like them. I suppose it's kind of weird that I use C# and then avoid using exceptions, because that's kind of how the language is designed. You don't need to use them though. I use enums. Let me see, for example, I just try to give things good names as much as possible. Yeah, I had a problem with multi-dimensional arrays entirely. Anyway, so you can kind of improve it. Say, for example, you have, let's say you have a function declaration, and the left would be the return type. So you'd basically you'd create something like, you'd say something like this, AST node, and call it return type equals something like, I don't know, node dot left, and then you know what it is, instead of saying what the hell is left, what's left. No, just simply create a variable return type. Oh, that's the return type. Okay, I don't have to think about what the hell left is now. Just doing that helps a lot, and then you don't get confused of what the hell anything is. But I'll show you how I say, for example, I go print debug data, print AST nodes. I'll show you how this works, because it basically just recursively calls it. So you have print AST node, which takes in a optional node, the indent, which is just simply for moving it from left to right, depending on how far we've done this, and the AST type text. I don't remember what that's for. Oh, that's the type of if it's left, middle, right, whatever it is. So if the node is null, we just return, because it can be null, because it doesn't go for, it will go forever if you don't have this check, and you'll get a Stack Overflow. So we have just a string builder for padding, basically just for adding spaces, because if I show you here, see here, this space here, it's just for that, that's all it's there for. So the amount of times we call it, we add one. So here I use fmt.print just because I'm really lazy, and I don't want to type in console.write. It's long. fmt.print is easier to write, and plus it's just quicker. It's quicker to write, and I can overload it with lots of fun. I can also print it, print line red, add different colors if I want. Anyway, it was kind of weird. I'm using C# not in a traditional way, but it's a very flexible language. So we add the padding to string, then we print the color yellow, and with the node type. So we're printing the node type. Then if the token is null, we're going to print the token. If it's not, then we say something like not any, like it's null. And then we check if they're null and go recursively calling all the other ones. That's basically how it works. We check if it's null. If it's not null, then we do this and we add 1, so it adds the space, and then we say what it is. It's left, middle, right, child. That's basically how it works. It's just recursive. It's basically just a linked list is how this works. So a few things here are kind of weird. So left, middle, right, it just depends on what you want. Children is generally for, say for example, you have a body. So a body could have maybe an if statement, then a declaration, then a for loop. So these are all nodes, and they'll all be in a list of children. That's how it would work. Is an array. I'm not sure if I really need that, but I guess I do. Is global, is constant. Size is for array size. Then I have definitions for finding definitions, because you need to find stuff and see if it's declared or not. It's very simple how I do it. I don't even have that much checking at the moment. But, I mean, there's still stuff I need to work on. It just takes a long time to make a language like this. But it generally works. I'll show you some other code if I can find some. I don't know if we'll get errors. If we get errors, I can show you some errors. It takes its time, bloody hell. It does waiting. Okay, now this is massive. I mean, look how big these AST nodes are. I mean, once you build it, it's not too hard, but building it is the main problem. That's a lot of tokens. Okay, I have a null token. That shouldn't happen. So obviously I haven't done parameters properly. Let's have a look. Why have we got a null token? Maybe that's, I don't know. I'm not sure if that's an error or not. This seems to work. Let's copy it into... so we haven't got an actual error in our program. So we'll see if this actually works in C++. Copy this. Okay, we've got 8 errors. Okay, this is a problem. Average grade. This should be a string, shouldn't it be? What's in the original? Okay, we have an error with the string. So I'm just going to fix that. I don't know why that's happening. Weird that that's happening. That shouldn't really happen. I haven't worked on this in ages, so this is it's very hard to read, because obviously there's no spacing, and the indentation's garbage. But you see there, it probably does work. Yeah, it works. Obviously that's terrible spacing. Out of 5, let me do this, wait. Out of space, 5 student space. It's basically just, I mean, I don't think I use floats here either. The average just returns an I32. It's very hard to read when it's std I32t. That's very hard to read. It's a lot easier just to write I32. But I wanted it to not be platform specific, so if it's an I32, it's an I32 on every platform. So this does work apart from the strings, which I don't know why was broken. So let's do something like this. Let's go I32 number equals 10, and we're going to go db alone. We're going to go print line. I don't remember how I write print line number 2. So it's an undeclared variable. We don't need anything here. Should probably put a return type as well. I don't think I have any checks for that. And then we call test code, and we should get an error for an undeclared variable. So here it says parsing done, formatting done, analyzing done, converting error, undeclared identifier in expression. So we have error on line 3, character number 7. I'm not sure if the line numbers are wrong, because if you count the line numbers, 1, 2, 3. Get off my screen. 1, 2, 3. Line 3 is actually correct. Undeclared identifier and expression, and we basically print the line before and the line after, and then the token is number 2. And then we have other things, undefined name, just other stuff. Of course, most of the debugging information you probably don't need to include. I probably don't need to include the error trace. That's just for me. Error trace is basically how did we get here? Like which functions did we go through? But I don't use exceptions. I'll show you how I don't use exceptions in any of this. So here, for example, we have pass result equals result, pass OK, and then we just pass it to tokens with the result and a reference to the result. And we say if the result is not OK, then we print the error. I'm not using exceptions at all. So if I do get an exception, something went really wrong and I didn't check for stuff. But it actually makes your programming, like you make your code more thorough. Because if there's any time where something could be null, you have to check for it. Otherwise, the whole program will crash and you don't get any information. So I don't. That's the last thing I want. So I basically never use it. I never use exceptions. Let's say, for example, we convert to CPP, and I'll show you how this works. So first we just have a massive struct for data, because I can't be bothered to have 10 million parameters here. So I basically have CPP data, which has the list of nodes, has the node index, which index we're on, the global definitions for what's defined, the generated code for the code we're actually making, error detail string, error token, so what basically, where was the error, what was the token, and we have in the token, we actually have, I'll show you in the token, we have the line number and the char number, so it kind of helps you in that example. I have completely lost where I am now. So yeah, back in CPP data, in structs, yeah, we have CPP result, the actual error result, and then the temp var counter is just simply for getting rid of duplicate vars, but it's basically just because if I didn't use CPP data and pass that, I would have to pass all of these parameters in, and that's terrible. So I basically just use a struct and then pass it by reference. I could use a class, and that passes by reference by default, but I prefer to be more specific, so I pass it specifically by reference when I call this. Where am I? Right, includes, I can't even read my code, it's been so long. Anyway, process node. Yeah, process node, we reference to CPP data. And then every iteration when we're processing the nodes, we simply check if there's an error. So if the, you could also just make it a class and make if error. But you could do something like this. You could have something like here, public bool is error, something like this. And actually remember what to write. And then we'll just return, what was this, CPP result not equals OK, like that. You could do this if you want, and then just call is error. It would probably save you a bit of time, but it does, I don't really care. Anyway, so if CPP is not OK, so it's an error of some kind, I'll show you the potential errors we can have. So we have no AST nodes, no functions, undefined name, unimplemented node type, node was null, assert failed, invalid CPP type, loads of different errors. But if it's an error, we print error in red, and then we print CPP convert error, which basically, I mean, I have a lot of this repeated stuff. So we get the line number from the token, then we get, again, we get the char number, then we get the code line. So we've got to separate the code into lines, so we actually know, how to split it and stuff. Split the code into lines, and we get the line of the actual, of this line. I believe we check, I'm not sure if we check if it's null or not. I think, yeah, let's have a look. Get code line, yeah, so basically it checks if it's in line. So again, I don't want an exception ever. So I check everything. I check bounds. I check literally everything. So if it's not, I just put invalid. That's all I do, put invalid. And again, I've just completely lost where I am. So then, yeah, we print the error on line this number, the error detail, and put it to yellow. And then print the code lines, which will basically just print, I think, the line number and the one above it. And print the error token and print error trace. Obviously, for the final version, you probably wouldn't want to have all this stuff. But basically, I don't use exceptions at all. I think only the few times I've actually used exceptions in this. Oh, here, for example, we have try catch. Oh, I'm using try catch. Look at me. Basically, I just couldn't be bothered to write if null return error, if null return error, if null return error. So I just basically use a try catch just to be lazy. Generally, I don't like to do it, and plus I'm using throw exceptions. Why I'm using throw exceptions? Because I'm lazy to implement it, and it's just an easy way to, it's broken, let me fix that. Oh, it's broken, let me fix that. Because I just want it to crash if something's really wrong. Obviously, if there's a null node type that shouldn't be null, I want it to crash and tell me. But probably the correct way to do it would be something like, so you do return, because it's a void,
and then you'd go CVP data dot convert, was it CVP result equals was it node was null, and then you'd probably have the error CVP error detail equals something like node was, you probably do something like left expression was null in for loop, something like that. Then you'd put the token, whatever the token would be. So if the load is null, you wouldn't actually have a token. So that's kind of a problem. But you could, in theory, just set it, say like error token equals, but it would probably give you an error, so it won't work. So you'd probably just say null. I don't know, but it's already null, so it's probably redundant. Anyway, so that's probably what I should do. I'm just too lazy to do this for everything, because so basically, if I'm lazy and just want it to just show me an error, I'll just throw an exception and never catch it, just because I want it. Just like, oh, it's null. Okay, just crash the program. Show me where. But in the final version, I will never have an exception ever. Like, I hate them. I hate exceptions because they're verbose, try-catch, blocks everywhere. I hate it. I'd rather use an enum and with detail. Anyway, so that's basically where I got to. I still have a lot of stuff to do, and I'm taking a break now. That's basically where I got to. It's quite a lot of work. I mean, it's not too much work once you get the ASTs done, but it's stuff like I want to implement structs. I haven't done that. I want to implement enums. Haven't done that. What else? Multi-dimensional arrays are a nightmare. They're a complete nightmare. Generally, what people do is they don't use them at all. Is they basically like simulate it. So say you have 2 by 2, you'd actually create a one-dimensional array of 4, and then just simply you'd multiply it by indexes to simulate having a multi-dimensional array, because having one is just a complete nightmare. Anyway, that's basically how far I got with my compiler. Let me know if you have any questions, and see you guys next time.